We are going to be on page 210 in your textbooks today. Okay, we're going to talk about simplifying expressions or combining like terms. Okay, what like terms mean is like if we have x's can only go with x's and constants can only go with constants. We can't combine a variable and a constant together. Okay, so like if we have this first problem here, we have negative 2c plus 3c minus 5 minus 4c plus 7. Okay. There's lots of things going on, but it doesn't have to be that complicated, okay? So I can see I have a negative 2c, a 3c, and a negative 4c, okay? So those are going to go together, and then the negative 5 and the plus 7 is going to go together. And I'm actually going to invert this because you're going to be watching it on the screen, and that'll help you see it a little bit better here. Okay? So if I'm doing this, well, negative 2 plus 3 is 1. Plus negative 4 would be negative 3c. Okay. Now the biggest mistake students make is they don't take the sign in front of the number. This is now a negative 4c. This is a negative 2c. This is a positive 3c. Okay. So we need to make sure that we are looking at those signs in front of the numbers. Okay. And then if we combine negative 5, because again I have to take the sign in front of it, and a positive 7, that's a plus 2. Okay, so this is the simplified expression. This is as far down as I can make it, okay, because the c's cannot be combined with a constant, okay? And remember, the negative 3 is what we call a coefficient, the c is a variable, and 2 is a constant. We should be able to name all three of those things, okay? So when we first started, we actually had 3 coefficients, 3 of the same variable, and 2 constants, okay? And you can see they kind of worked that out here. They did it a little differently, like they used the commutative property to reorder them and then put them together, which is fine. There's nothing wrong with that. In my brain, it just gives you a lot more steps to do rather than just combining like terms. Okay. Again, I'm not going to worry about the boxes over here. Let's look at this, try it. So we have negative 6 minus 6f plus 7 minus 3f minus 9. Again, when I'm doing these problems and I have a bunch of stuff, okay, I like to be like, okay, negative f, or negative 6x, negative 3f, those are going to go together. And my constants are going to go together. Those are my like terms, okay? So negative 6f minus 3f, okay, again, we have to take those signs in front, is negative 9f, okay? And then negative 6 plus 7 would be a positive 1, minus 9 would be negative 8. So my final answer would be negative 9f minus 8. Okay. Again, we're combining like terms together. Remember, those signs in front of the numbers are very important. Okay. And our negative rules that we've learned about from the beginning of the school year still apply with adding and subtracting, multiplying and dividing. Okay. It says, how do you decide in what way to order the terms of an expression when simplifying? We're not really going to reorder, but typically you want variables first and constants second. Okay. It's not really a big deal. If we had written this previous one as negative 8 minus 9f, they mean the same thing. But what happens is when we get to algebra, it's helpful to have the variable part first and the constant second, even when we go into solving equations into our next chapter. Okay. Please make sure all of your notes are being written down. Even though I'm not here, I still want to see those notes, okay? This one, we got a lot going on this problem, okay? And what it is we're just combining variables. We're combining decimals and fractions in what we already know, okay? So I'm going to go ahead and erase this so I can talk through what's happening on each one of these, okay? Again, I'm going to do the same thing. I'm going to say, okay, I have a 1/3 x, and I have a negative 1/5 x, and then I have a negative 3 and a negative 4.5, okay? So off to the side, I'm going to be like, okay, I know I'm doing 1/3 minus 1/5. I know I need a common denominator, which I'm going to make both of them look like a 15. In order to get 3 to look like a 15, I'm going to multiply by 5, so I have to multiply the top by 5, so it becomes a 5. Over here, I have to multiply the bottom by 3, so I have to multiply the top by 3, which is a 3, because 1 times 3 is 3. 5 minus 3 is 2, so I get 2/15 as that fraction. So I'm going to have 2/15 x. And then if I do negative 3 minus 4.5 is minus 7.5. Okay, and you can see conveniently that's what they got as their answer too. Now you could write it as plus negative 7.5. Either would be acceptable. I personally like to only have one symbol as much as possible. Okay, and you can kind of see actually that's what they wrote down here as well. Okay, so I would accept either on a test, neither is wrong, but I just prefer this method over here. Oops, undo. I just prefer this answer over here. Okay. All right, let's practice some more. We're going to simplify expressions with decimals and whole numbers. So again, I'm seeing I have a bunch of m's. I want to get those m's together. So we're going to have 59.95m plus 7.95m plus 9.49m. So if I add those together, 59.95 plus 7.95 plus 9.49, I'm just going to add all that in the calculator. And so that becomes 77.39m. And then negative 30 plus 45 would be a positive 15. And this is my answer. Okay. Again, I have 77.39 as my coefficient, m is my variable, 15 is my constant. Okay, moving on to this next one. Again, it looks like we have a bunch of p's, so we have a 1/2 p plus 2/3 p. And then I'm going to combine, and we also have, a negative 0.5 p. Okay. And then, so this negative 2.75 is just going to come along for the ride in a little bit. Okay. So I know negative 1/2 and 1/2, well, this is just 1/2 p, negative 1/2 p plus 1/2 p. That's just going to be 0, so I can just cross that off. And then I get 2/3 p. If those didn't cancel out, I would just get a common denominator off to the side, but make your life easy, right? If something, when they add together, is going to cancel out, why not do it that way? Okay? So yeah, I just want to make sure that was a plus and I wasn't imagining things. Okay? All right, now sometimes we'll have more than one variable, and that's okay. We can deal with that. So in this case, we have A's and B's. So A's can only go with A's, and B's can only go with B's, and constants can only go with constants. So I'd be like, okay, I have a 4A and a minus 3A. And I'd be like, okay, that's 1A. And then I'm going to be like my B's. Okay, I have negative 5B plus 2B. So that would be negative 3B. And 6 doesn't have any buddies to go along with, so we just have negative 6. Let me write that in a different color here. So we have minus 6. Okay, so we're going to have A minus 3B minus 6. I don't care if you write it as 1A or just A. Either would be acceptable. Okay, but again, just A's have to go together, B's have to go together, and the constants have to go together. I cannot combine this to be like, oh, it's negative 2AB. Like, they're different variables, can't combine them. Okay. All right, moving on here. Again, I'm not really going to fill in these boxes just because they make it more difficult than it has to be. So I'm seeing I have G's, I have K's, so I'm going to say, okay, I have 5G minus 10G, which would be negative 5G. I have a K, and there's no other K's, so I'm just going to write that here. And then we have negative 3.7 plus 11.1, which you can use a calculator if you so desire. Okay, so these have to be combined together to give us a positive 7.4. Okay, and so this is our final answer. Again, nothing else can be combined because we have G's, we have K's, we have constants. Okay, so there's no other like terms. So the like terms here were the G's and the constants. Okay, and I believe that's our last problem for today. Yes. If you have any questions, I want you to try your best on your homework. I'm leaving you the answer key, and any questions that you have, we can answer tomorrow. Have a great day. Bye.